We use it every single second of the day, but the system that powers our lives, it's almost completely invisible. So today, we're going to peel back the walls and follow the incredible journey electricity takes from the street right to the screen you're looking at now.
Let's dive in.
It seems so simple, doesn't it? You flick a switch and boom, the light comes on. You plug something in and it just works. But you know, that simple action is really the final step in a super complex, powerful, and very carefully designed system. We're going to trace that whole system from start to finish.
All right, so our journey starts right outside your door, with those power lines you see running down the street. This is the first leg of the trip, where that raw power from the utility company gets prepped to enter your home.
Okay, take a look at this. This diagram is basically our roadmap for the whole trip. You can see the power coming in from the utility pole, then it moves through the main switchboard and panels, and finally, it branches out to every single light, outlet, and appliance. It's the whole system in one shot. So, the very first stop for that electricity is a transformer. You can think of it as a bouncer, or maybe a tamer. It takes this really powerful, super high voltage electricity from the main lines and steps it down to a much safer, more manageable level, usually around 240 volts that your home system can actually handle.
Next up is the electric meter. This thing is the official scorekeeper. It's carefully measuring every last bit of electricity you use. And its placement is totally intentional. It's always installed before the main shutoff switch, so your power company can always track your usage.
Okay, once it's inside your house, that electricity is funneled to one central location. This is the command center, really the heart and brain of your entire electrical system, the main service panel.
Believe it or not, all the power for your entire home comes through just 3 main wires, which you can see right here. 2 of them are hot and 1 is neutral. This setup is what gives you the different voltages you need to run everything from your tiny nightlight to your giant oven, and it all feeds directly into that main panel. Now inside that panel are rows of these things, circuit breakers. And let's be clear, they are not just on-off switches. Think of them as tiny automated bodyguards for your wiring. If a circuit gets overloaded, you've got too many things plugged in, the breaker instantly trips, cutting the power to prevent overheating and, potential fires. It's an absolutely critical safety feature.
And if we take a closer look inside, you can see the main disconnect switch, usually at the top. That's the big one that can kill power to the whole house. And then below it, you see all those individual circuit breakers, and each one is protecting a specific area, one for the kitchen, one for the bedrooms, and so on.
So, the power is now in the command center. How does it get to every room? Well, this is where a hidden network of electrical highways, kind of like a nervous system, spreads throughout the walls of your home.
Each one of those breakers we saw on the panel feeds something called a branch circuit. You can see it visualized here. Think of them like arteries carrying power to specific zones in the house. This design is really smart because it's why tripping one breaker only kills the power in one room, not the whole house. It's a great way to isolate any problems.
Now these highways themselves come in different forms. The 2 you'll see most often are Romex and BX. Romex is that non-metallic plastic-coated cable that's super common in houses today. BX, on the other hand, has a protective metal armor around it, which makes it a lot more durable for certain jobs.
And here you can really see the difference side by side. On the left is that spiral metal armor of the BX cable. It gives it a ton of physical protection. And on the right, you've got the simpler plastic-sheathed Romex cable. They both do the same job, just in slightly different packages. And for the highest level of protection, we're talking maximum security here, especially in commercial buildings or where wires might be exposed, they're run inside these tubes called conduit. They actually install the tube first and then pull the individual wires through it. It's like an armored tunnel just for the wiring. We followed the power from the street, into the panel, and through the hidden highways in the walls. Now we finally arrived at the last stop, the everyday switches and outlets where we actually get to use all that electricity. This is such a cool behind-the-scenes look. It's what's called the rough-in phase of construction. Before the drywall goes up, you can see all the outlet boxes fastened to the studs and the wiring getting run to them. This is the hidden infrastructure that's sitting right behind your walls. Okay, you have definitely seen these before, right? Those outlets in kitchens, bathrooms, garages, the ones with the little test and reset buttons. They're not just for decoration. They're an incredibly important life-saving feature. So, what do they actually do? They're called GFCIs. That stands for Ground Fault Circuit Interrupter, and their job is to constantly monitor the flow of electricity. If they detect even the tiniest imbalance, like if electricity starts flowing through water or worse, through a person, they slam the power off in a fraction of a second to prevent a dangerous shock. That's why they're required anywhere water and electricity might mix.
And have you ever noticed just how many outlets there are in a modern room? Well, there's a reason for that too. The National Electrical Code has what's called the 6-foot rule. Basically, it says you should never be more than 6 feet away from an outlet along any wall. The whole idea is to cut down on the need for extension cords, which can actually be a pretty big fire hazard.
And finally, the humble light switch. Its function is just beautifully simple. A switch is nothing more than a gate on the hot wire. When you flip it off, you're creating a physical gap in that circuit, safely stopping the flow of electricity and turning off the light. Simple as that.
So, we've completed the whole journey. We've seen exactly how power gets from the pole to the plug. But the story doesn't really end there. How we use that power, that's just as important.
So next time you're out buying an appliance, look for this yellow Energy Guide label. It's basically your personal tool for managing all that electricity we've been following. It shows you the estimated yearly energy cost, and that lets you make smarter choices that can save you both energy and money.
So, where does all that energy actually go? This chart gives us a pretty clear answer. And it's fascinating, right? Kitchen appliances take up the biggest chunk, a whopping 29% of a typical home's electricity use. That's more than air conditioning, more than heating, and way more than lighting. You know, from simple wires hidden in the walls to today's smart panels and networked appliances, this whole journey is constantly evolving. The system we have today is a true marvel of engineering. But as our homes get smarter and our energy needs change, it really makes you wonder, what's this journey of power going to look like in another 50 years?